So as I was hustling through the end of the lecture yesterday, I remember drawing a box here. And the explanation that I had in regards to the box was that if there were a number in that box, then it would cause the entire graph to move up or down.
Mhm.
Basically, what that means is that the horizontal asymptote moves up or down. Understand this about graphs, that as the asymptotes move, the whole graph physically moves with them. It is the skeleton of the graph. So what I was trying to say yesterday was that if there was a +3, the graph would go up 3 or whatever. If you have a rational function that looks like number 6, where it is just some stuff over some stuff, that's what I was trying to get across yesterday. And again, the bell had its way with me. But there, do you guys remember the three scenarios for horizontal asymptotes? Sometimes there isn't one. What would be the case for there to not be one?
If the top is smaller, is what I
No.
wrote to you.
If the top degree
If the top
is higher than the bottom degree, then we would say that there is no horizontal asymptote. And FYI, we are not even going to go down that road for at least another probably week or two, because sometimes those will have what we call slant asymptotes. So I don't even know why I'm bringing that up. I'm just telling you that if by chance you see one, that the degree on top is bigger than the degree on bottom. So like if I wrote for you a function like f of x equals 2x to the third minus 4x plus 11 over x squared minus 2x plus 4. If I said, where's the horizontal asymptote? Your job would be to say none. It doesn't have one. And the reason I would say is because the degree on top is bigger than the degree on bottom. I think we're a ways off. I don't feel like why would we talk about this and not at least cover all of our bases? So that is a possibility. It's just not going to be something that you're going to see anytime soon. Okay. So back to this one then. We talked about one of the scenarios just now. You said if the degree on top is higher than the degree on bottom, there's no horizontal. What are the other two scenarios?
it's it's lame.
If they're the same, but I shouldn't use pronouns like they. If the degrees on the top and the bottom are the same,
Then
and
it
Brenna,
comes
you
down to
chucked
the
this one
rate
out
of
yesterday. I was
fraction.
impressed. Then the ratio of the leading coefficients builds the fraction that is the horizontal asymptote. And so again, let me go to my other page and just give you a simple example. So if you were going into a function g of x and it said, 4x squared minus 11x plus 9 over negative 8x squared plus 3. And I said, is there a horizontal asymptote? You would say yes. And if I said, where is it? You would say it is at y equals negative 4/8, right? Okay, so scenario one, if the degree on top is bigger, there isn't a horizontal. Okay, and the reason for that is because there's no like horizontal limit. If your degree on top is bigger than your degree on bottom, then as you put infinity in place of x, the top grows quite literally infinitely quicker than the bottom, which means it never has that horizontal location. Not sure if I'm saying that right, but like that location that would be a horizontal line, it can't approach that because it's limitless, so to speak. Um, so anyways, I digress. And if the degrees are the same, then we go at the fraction of the leading two numbers. What's the third scenario?
It's less than if the one on top smaller
Then
and you
correct. And that leads me back to why I drew that purple box yesterday. So what we don't want to get roped into is saying something stupid because your teacher's a knucklehead. So like if the function is f of x equals, um, x plus 3 over x squared minus 6x plus 4. If the function stops here, you can say, take it to the bank, the horizontal asymptote is at 0. Got it?
Mhm.
However, back to the purple box, if there's a number at the end, like +2, what does that do again?
It just says it.
it shifts the horizontal asymptote. You essentially grab that horizontal asymptote with a pair of tweezers on either side, and you lift it up 2 and you redrop it. And as you drop it, you also are moving the whole graph, like all the curvy arms come with the skeleton, right? So I'm just throwing this in as an addendum so it doesn't come back to bite me that I say there's always 1 and 0. It's true, provided that it's just one fractional thing. A number at the end causes changes, right? Okay, so those are our 3 scenarios with horizontal asymptotes. And let's talk about vertical asymptotes. Where do we find them at?
On the inside of the
Oh boy, that was rough. So let's talk about vertical asymptotes, the ones that go like this. Where do we get them from? How do we figure out if there are any or what they are?
You have to factor out the numbers and then figure out which ones of those factors we can erase. And then the ones we can't.
Be a little bit more specific. Where will I find my vertical asymptotes? Thank you. The denominator, and I think you all knew that, you just weren't saying it. The denominator is where you get your vertical asymptotes from, okay? So what I'm interested in when I go into this, so we're back to problem 6. We all agree there's a horizontal asymptote at y equals 0 because the degrees are 1 and 2. And there's no number at the end to change it. So now if we get into the vertical asymptotes, and this is where you've got to just know some basic kind of algebra 1, algebra 2 factoring stuff. You really want to fixate on the bottom. So if I asked you to factor the bottom, what would be the first thing that you'd do? So we're factoring negative 2 x squared plus 10x minus 8. What do we do? You pull a negative 2. You should always factor a GCF. And if the leading term is negative, you should always pull that out. You've heard this lecture before. So I'm going to pull out the negative 2, and that's going to leave behind x squared minus 5x plus 4. Everybody agree? Okay. And then I want to factor it one step further and say, okay, so the bottom of this fraction equals negative 2 times x minus 1 times x minus 4. So I don't know if I can do this or not. I don't know if the pen lets me. I'd see if I can cheat the system here a little bit. But if I erase the bottom, I'm going to see if it'll let me write over the top of it. Oh, hey, that's pretty slick. So this is what the problem actually now looks like. And we're in vertical asymptote mode now. So what do you see on the bottom? Like what catches your eye?
Yeah.
That's interesting. I agree. The fact that these two that I'm about to cross out is significant. But I'm going to undo that. What else do you just tell me? What are we thinking at this point? Give me 2 bad numbers. 1 and 4 are bad guys. We need to be perfectly clear that if x equals 1, something bad happens, right? Because you know that you're not allowed to have 0 on the bottom of a fraction, correct? So if x is 1, that's bad. We'll talk about what kind of bad in a second. If x equals 4, that's bad. Listen, anything that ever makes a function stop and say no can do is bad. So the question now becomes, who's a fixable bad guy and who's a non-fixable bad guy? Who's the non-fixable bad guy? 1 is. He doesn't have anyone on top that's going to make him go bye-bye. So we can say now that because I can't remove the x minus 1, that there is a vertical asymptote at x equals 1. There's not a darn thing we can do about that discontinuity. Because 1 makes this purple factor equal 0. And there's, again, nothing I can do about it. So I'm going to go ahead and while I'm thinking of it, I'm going to head over to x equals 1. And I'm going to draw a vertical asymptote like this. And, while I'm here, I might as well draw my horizontal asymptote as well. So I'm going to go to where y equals 0, also known as the x-axis, and just draw in an asymptote. What I have right now is then what I would call the skeletal structure of my graph. But let's talk about that x minus 4. What happens at x minus 4? It's a hole because I can take my pen like this and I can go x minus 4 and x minus 4. You guys are the same. So you are now what we call a removable discontinuity, aka a hole. So we're going to say that there is a hole at 4 comma blank. And to be clear, that should be a blank for the foreseeable future because now we have to go math. And we had a great conversation about this yesterday about where should I put the number 4 to figure out the y coordinate of the hole.
You're low already factored that.
In your already factored and cleaned up function. The function that I would be using to test the number 4 would be f of x equals 1 over -2 times x minus 1. That's the function stripped down buck naked with its common x minus 4s canceled out. That's it at its DNA level. And now we're going to take the number 4 and we're simply going to do some basic math. We're going to plug it in right there. What is 4 minus 1? 3. What's -2 times 3? And what's 1 over -6? It's -1/6. At this point, I feel like we did a problem that was just like this on was it the front maybe?
Yeah.
Or somewhere else, but boy, this feels like deja vu to me. So at this point, it's very difficult to do, but I'm going to zoom in and I'm going to try to draw a hole at 4 -1/6. So I'm going to go right 4 and I'm going to go down just a little bit like this and draw a hole. It should look like a hollow circle. And then I'm going to zoom back out. And knowing what we know about rational functions, we have a pretty good idea that the graph is going to kind of see how I'm moving my pen. It's going to behave like that down in this quadrant here. But I still think you should have a little bit more to hold on to. So let's go and put 3 into the function. If you put 3 where the yellow arrow is pointing, what's 3 minus 1? 2. And what's -2 times 2? -4, and 1 times 1 over -4 is -1/4. So what I'm trying to do is give myself more points so that I have more stuff that I can connect. We're expecting when we put 2 in here that the graph had better start to go down, right?
Mhm.
Otherwise, the universe is like misaligned and things aren't working. So what I'm trying to say is our next value had better be like somewhere inside that green circle. Otherwise, the graph's not behaving the way it ought to. So I'd like to put 2 in place of x. Everything has been for years predicated on your ability to not be bad at basic math. So what is 2 minus 1? 1. What is -2 times 1? -2. And if you put 1 over -2, you get -1/2. And sure enough, look what's happening. That dot is now lower than its predecessor. And we could keep repeating this process, but we're about to come up and butt into the asymptote. So at this point, you can just start to predict the asymptotic behavior. You know quite well that as you get closer and closer to that asymptote, that your answer is going to get lower and lower and lower. So you'd be fully green lighted at this point to just get in there and sketch the graph. And by no means is it a simple process. It looks like your graph is almost on top of the horizontal asymptote. This is a very pronounced tight graph. And on a piece of paper, especially this size grid, it's super hard to not make it look like poo-poo. We now know we're going to have a clone of this, but again, as things change over the coming weeks, our graphs, we cannot and should not assume that the other arm of the graph is it's very lazy and presumptuous to say, well, it's just going to be over here. Don't do that. Okay, give yourself at least one piece of evidence to verify that that's the case. What would be a really convenient number that's left of the vertical asymptote?
-6.
Yeah, I mean, I would have said 0, quite frankly. I don't know why you guys are making everything harder than it needs to be, but 0 is conveniently to the left of the asymptote. And if I put 0 in place of x, where the yellow arrow is pointing, what's 0 minus 1?
-1.
-1 times -2 is
2.
So the answer would be if I put in 0, I get 1/2. Therefore, I now have enough evidence. Right there is my evidence. That one red dot is all the evidence I need to say I know exactly who you are now. I know you're going to behave exactly like your homie in the southeast, and you're going to go like this. You're going to behave asymptotically in the same way, like that. I do want to respect your time and allow you to work, but I also don't want to slight you of information. So would you guys like to pick another one to do together? How can I best be of service to you? Um, you know how I roll. It's not like,
Mhm.
I'm not going to punish you and make you go home and get this done. So it's your learning is what's important. Are there any others that catch your eye?
Mhm.
All right. Well, let's do this. I'll hand out the next assignment and you guys just work. And then as you encounter something that your teacher forgot to talk about, then just let me know and we'll talk about it together. But I did look at this worksheet and honestly, it's not very flavorful, which I almost changed it and I was like, actually, maybe a flavorless assignment might be a good introduction into this for us. So it's not too exciting.
Yeah.
But it is assignment number. There's no way this is not right. This says assignment number 26.
It should be assignment number 67.
My God. I don't even know why I talk to you sometimes.
I do believe that is correct.
Is it? Are we honestly on assignment 26?
Mhm.
So here, I didn't want to say this because but there's going to come a point where you have to know that what I'm about to say is an unavoidable truth. You can cross over horizontal asymptotes. It's not the kind of thing I want to talk to you about right now, but it can happen. Vertical asymptotes are no way. Lava, death, fire. Vertical asymptotes are non-negotiable. You do not cross them. However, a horizontal asymptote is like a limit, and a graph can actually go down and get under a vertical asymptote and then settle back into it from the bottom side. Or conversely, it could come up and go through it from the bottom and then resettle from the top side. Horizontal asymptotes are not the untouchable weirdness that verticals are. So if you ever do find yourself, I know in this case it might have been a mistake, but if you do find yourself feeling like I crossed my horizontal, it can happen. The horizontal is like a limit more than anything else. What's happening over there? So you just want a fresh
2
copy.
minus 2.
Through
Is zero.
along the line that was not the red line.
So let me pause this real quick so then I can make fun of you here real quick.